This is the output from a test of normality. Just going to have a little look through here first of all. You get a little summary table that tells you that you have 50 cases, and this is the variable that you've looked at, the one called RT. Then you have a table of descriptive statistics, including the mean, the median, the variance, and so on. And at the bottom, we have skewness and kurtosis. These are obviously to do with the shape of the distribution of the scores, which is what we're focusing on and interested in. This is the test of normality table. It gives you two different statistics, one called Kolmogorov-Smirnov and one called Shapiro-Wilk. Now, generally speaking, Shapiro-Wilk is used for small samples. So if you have a sample size of less than 50, you would look at the Shapiro-Wilk figure. Kolmogorov-Smirnov is used for samples of about 50 or more, so we're going to look at this one because our sample size is 50. If you look at this significance level in the column called sig as normal, it tells you that the value is 0.000. Now obviously that's a rounding error, so it can't be exactly 0, but it's clear that it's smaller than 0.05. So we have a significant result. Now what this means is when it's run this test is that the shape of the distribution is significantly different from a normal distribution. So in test of normality, if you have a significant result, it's bad because it means your distribution is not the same as a normal distribution. So we've got a significant result. So we know that these data are not normally distributed. So we need to then find out why. Well, the first thing we can do is just scroll down and look at the shape of the histogram. If you look at this, we can see that we have a positive skew. There's a lot of scores piled up at this end, and then there's a long tail stretching off in the positive direction. So it looks like we have a problem with positive skew. Now, in order to check that, go back up to the descriptives. If you look at skewness, if this number in this column is more than twice the size of this number in this column, so if the statistic is more than twice the size of the error, then that's where the problem lies. So obviously 1.9 is quite a lot bigger than 0.33. So it's confirming that statistically these data are indeed positively skewed. Now what we can also look at, right at the bottom of your output, is the box plot, or the box and whisker plot. Now this shows us that we have these participants here and their scores that are statistically outliers. These lines here extend 1.5 times the interquartile range from the middle of the data set. So anything beyond that are considered to be outliers. So, and these are the case numbers, so 4, 9, 11, 13, 21 and 10. So they're the numbers of the participants in the data set. So we can see that we have some outliers. So now we've identified that we've got some problems. We've got problems with outliers and problems with skewness. So now we'll consider what we're going to do about it next.